All right, so I just pasted in the question and a node definition for you at the top there. So why don't you just give the question here a read through and let me know if you have any questions, and then get started with your thought process.
Sure. So the prompt says, given head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. Given the decimal value of the number, return the decimal value of the number in the linked list. Okay, so my thought process is that we are given a linked list in the main, and then we're going to use this function getDecimalValue to convert that linked list to the decimal value. So the way that I'm going to implement the getDecimalValue function is we're going to say that our current, what the part of the linked list that we're going to currently look at is the head. And then we're going to loop through the whole linked list until we get to the very end of the linked list. And for each node in the linked list, we're going to OR it. So we're going to shift it first, and then OR it with the current value, and then update the current value. So I'll write out my logic there, just above this.
Okay.
So I'm going to say, so for instance, if we have, so say we have our number 1, 0, 1, we're going to say that that is our linked list. And we're going to have a result variable. Like that. Yeah, so we have our result variable, the way you have it here.
Yep.
And we're going to say that we're going to look at the current node, and we're going to say that the head is the current one that we're looking at. And then we're going to have a while loop that says while the current node is not pointing to null. The reason that we're going to use that as a test is because the last node points to null. So that means that once you hit that one, then you're at the end of your list.
Yep.
So we're going to shift the result to the right, to the left, which is basically like multiplying by 2, which is what you're doing with every shift of a binary number.
Right.
Which is by 2. Value at the current node. And the reason why we do that is because that's the method that we're going to use to convert the binary to decimal. So use OR to convert binary to decimal. And then our current value is going to get updated to point to next. So then current points to next. Excuse my typos. Yeah, so that's the idea for the getDecimalValue. And then the int main would be, the main function would be pretty basic. It's just going to send the linked list to the decimal value function.
Yeah, don't worry about writing the main. We can just assume that this will get called with, some properly formed linked list.
Okay. Okay. All right, cool. So I guess we're going to go ahead and implement this with the outline that I put above. So we're going to have a integer result, and we're going to initialize that to 0. Then we're going to use a while loop. So while the head is not equal to okay, so then our result is going to be shifted by 1, which is like multiplying by 2. And then next up, we need our semicolons to run C++. And then we're going to use an OR function to convert the binary to decimal. So I'm going to say OR. Well, actually, no, it's supposed to be our current pointer. And we need to create a list node to start. And the current node is going to point to the head. So I forgot to implement that, but we need that.
Yep.
So while current is not equal to null pointer, result is result shifted by 1. We're going to OR the result with the current value. And that value is going to be a 1 or a 0. And then we're going to update the current so that we can loop through it and say current. Yeah, so we're going to shift our current value down the list. And that's the way that we're going to move through the linked list. And this is going to happen until we reach this null pointer.
Yep.
And because this is an integer, this result is going to get returned. So we're going to say return results. And this is going to be our decimal representation.
All right.
Got my semicolons. Yeah. Okay. Yeah, I think that would be my response to this.
Okay. Yeah, great. So that's right. I followed the logic pretty well. So then off this, what is going to be the time and space complexity for this?
So the time complexity would be, I think it'd be linear time, so O of n, because we iterate through the linked list once, and we only use the information there, like at the time that we're looking at it, if that makes sense. So yeah, basically linear time.
Okay, and then space?
For space, we are, well, we have a variable sized list, and for each, well, it depends on the length of the list only, so I think it would also be O of n, because because you're not creating like any large arrays or anything like that. So I think it'd be linear space also.
So why linear? So what space are we adding?
We added a result variable. Yeah, so just the result variable we added to this.
Okay, and then that's going to be, that would actually be constant time in this case, because nothing, on order n is going to dictate the space. No matter what, we always just have to have a couple constants in here.
Oh, okay.
So because you need an integer return type of you have to add the one little variable here, and then this is just like you could think of it as equivalent to this. It's just adding like an iterator for us. So you're not like constructing a new linked list of size n or an array of size n or anything like that. So as long as you're not creating space on order n, then space will be constant.
Okay, that makes sense. Cool.
Yep. Yeah, space is a little tricky. Time is usually fairly straightforward for some of these easier questions, but space is tough to wrap your head around. That even though you have these like temp variables and whatnot, it still is going to be constant time because we don't need to like copy the linked list or anything like that. So
I see. Okay, cool. Awesome. That makes sense.
well, yeah, good job.
Thank you very much.